All right, you guys. So welcome to our first video. So first of all, I am not going to be putting my mug on each of these videos, so you don't always have to just stare at me doing this. But I wanted to, for this first video, just take a few minutes to talk to you about a few things. So we're going to start with section 7.1, and that's talking about ratio and proportional relationships, okay? And what I really want to emphasize with you, and it's really hard with this because we don't have any discussion, and that's my favorite thing about this class is getting to talk about, different topics and concepts and sharing them with people who want to be teachers. Teaching is a hard job, and I admire everybody who wants to do it, and it's been a passion of mine, and I love it. Online is difficult, especially with this, because we can't necessarily do all the manipulatives and the games and the group work that come along with how this is taught and how I would expect teachers to be teaching it in the classroom. So I apologize that we aren't able to do it full force, but that's okay. And I know that you guys had a great 1100 course online, most of you. So you're probably used to that, okay? But anyway, when I refer back to 1100, I'm just referring back to what the material that was in there. So if you ever have a question about when I say, this is what you should know, and maybe you didn't talk about that, because we kind of pick out the topics that we feel are important. And so just let me know. You shoot me an email and we can talk about it, or we can do a Zoom if you need to. All right. So what I wanted to talk about really quick before I get started on the lesson is the purpose of this. And the purpose of this class is that all of you hopefully want to be teachers, and I'm sure a majority of you are elementary, some might be middle school, and some of you might be high school. And so Math 1100 is really geared toward elementary students and learning the higher level, but the elementary students, in the fact that you're doing fractions, decimals, number lines, base 10, all that, and that's where they learn that is in the elementary. So this course is going to be more towards middle school, and I mean, not teaching high school, but knowing the high school concepts, because you need to understand the pathway and the progression of where the students are going so that you are steering them in the right way, right? And I think that's something that some elementary teachers struggle with, and I don't blanket that. It's a hard thing. You didn't come out of college to be a math major, but you have to teach math. And so teaching math requires you to know the subject and know the content. And that's in order for you to be able to teach students how to think deeper. And I think we haven't had much of that. And so some teachers have really struggled, and some are excellent with it and they don't have any problem with that. And you all will be too. But, if you struggle with the content, it's really hard to teach it. And that's what this course is for, to help you understand mathematics so that you can teach students. So what we always have to keep at the core of this is that we are teaching students. It's not about us. It's not about, we have to do what's best for our students. And that's hard. And that's being able to admit that I don't understand this, and going to a colleague and saying, can you help me out with this? Because I really am not sure how to teach it. I'm not comfortable with it. And that's okay to do that. That's okay. Research it, Google it. Find other teachers. Don't be afraid to say that. We even at the college level still go, what the heck? How are you doing this? Because this isn't working for me. We all have that. And so you don't ever feel ashamed or feel bad about asking for help when you need it, because that's what teachers do. We share things and we help each other. We do a lot of group work. And that's what we need to do. And that's what this class is kind of about, always understanding the student's perspective, because you're going to have students that are at all different learning levels, that learn different style teaching, right? And so we have to adjust our teaching styles to our students. And that's a hard thing to do. It is. It's a hard thing to do. But you will be it's so fulfilling when you see that your students understand and the light comes on and they understand, the skills and the topics and the concepts that you're trying to get across, and that they can talk about it and they can use math language. And so I don't want to bore you on this. I just can't emphasize enough of what your purpose is. And your purpose here is to always figure out what's best for students. How are my students going to learn? I've got to show multiple ways. We've got to figure out different ways for students to learn. But in order to do that, I got to understand the math as well. All right. So we're going to go ahead and start today with 7.1, again, on proportional relationships and ratios. And like I said, I know you've taught this with strip diagrams when we did parts with fractions. at the very beginning of Math 1100, and just teaching that with learning part to part, part to whole. Okay, that comes into play here now. So you see what happens at the elementary level. Now let's come into this grade level and grade middle level 6 through 8. Okay, and let's see how that then is going to progress eventually into the high school level. So I'm going to go ahead and switch my screen here, get my camera up. And we're going to talk about section 7.1. So what we're going to talk about is defining what a ratio is. Okay, because now they really know what parts are, but not necessarily a ratio. Okay, some do. You know, you might have mentioned that early on, but it's really kind of a precursor for this. And then we're gonna work with multiple batches, variable parts, and then just kind of talk a little bit about what proportion is. Okay, so let's talk about just defining a ratio. So how we define a ratio is, remember, a ratio is it's a set. It doesn't change. It's a fixed ratio. Okay, so a ratio is a fixed ratio. So let me just go through an example here. So let's say we want to make a punch. All right, punch is always an easy one to use here. And so we want to have a punch that is 2 cups of juice, and let's just say 3 cups of let's go Sprite. Okay. All right, so 2 cups of juice and 3 cups of Sprite. Now, if I do a batch, how many total parts are here in it? There's a total of 5. I have two juice, 3 Sprite. So there's a total of 5 parts in it, right? So let's go ahead and just do a strip diagram with 5 parts. All right, now each of those parts are 1 cup. And so 2 cups of those are juice. I'm going to use a different color here. I don't know if you can tell the difference. And then 3 cups are going to be Sprite. So here's our Sprite. From here to here is our Sprite. Okay, and then here is our juice from here to here. Now, that would be 1 batch, right? Would you agree? That would be 1 batch. 2 cups juice, 3 cups Sprite. So that's beginning talking about our ratio. Now, let's talk about a multi-batch. Okay, now something I could do here is I could do this if you want to, the dot dot, and that's a form of showing a ratio. Or you can do it as a fraction, okay, but let's just kind of go through this and then you can decide, you know, you might need to do both and show how to do ratios with that. All right, now let's do a multi-batch. And this really, I don't think should be new to you either. So a multi-batch, let's say we want to do 3 batches. Okay, so you know, you agree that these are fixed, right? They're all 1 cup. So we're going to do same thing. All right, so we got 1 of those. Now that's 1 batch. I'm not going to change all the colors this time. Well, maybe I should here. All right, so now let's do a second batch. Okay, again, here's our second batch, and then 1 more. We'll do a third batch. All right, so here's our multi-batch for 3 batches. Now, would you agree that this is still a fixed ratio? This is a fixed ratio. They're all 1 cup. Here's 1 cup, here's 1 cup. The only difference is we have multiple batches. So here's 1 batch, 2 batch, 3 batches. So what we want to do on this multiple batch is, again, so here, how many cups is it going to be for each of them? Well, we have 2, 4, 6. And then 3, 6, 9 adding up. So for 3 batches, this is how many total cups we would need. Okay, so that's just showing a multi-batch. But what I want you to recognize, it's a fixed ratio. These numbers don't change inside the box. It's fixed. All right. So now let's move on to what is a variable part. So instead of multi-batch, just going to emphasize that. Okay, we're going to do a variable parts. Oops, that's a B there. All right, so variable parts. Let's take a look at that. So again, we want to do variable parts, but let's go ahead again and do 3 batches, but showing it a different way. So variable parts, again, we have 5 total parts. Okay. But the difference now is the number that goes in here, and that's going to vary, which is why this is called variable parts, because we can do however many batches we want. If I wanted to do 100 batches, you're not going to draw out 100 single batches, right? So you don't want to use the multiple batch system for that. So for variable parts, if we want 3 batches, then that just means we would have 3 batches here, 3 batches here. So, and then 3, here's your Sprite. 3 of each is your Sprite. Okay. And so again, if I added that together, you see where you would have 6 to 9. Now let me show you real quick. When we start doing the variable, a variable means it's an unknown. We don't know what it is. So here we have, let's see, here juice we have 2 parts. And then here we have 3 parts. And so we're going to figure out what those ratios are. So N stands for the number of batches. Okay, so if we have 3 batches, we would take 2 times 3. Okay, and then we would take 3 times 3. You with me? We have 2 parts of 3 batches and 3 parts of 3 batches. Okay, I have all my pins showing out of the way there. Okay, so 2 parts of 3 batches, 3 parts of 3 batches. So then that gives us this ratio, again, of 6 to 9 for 3 batches. And that's the total cups. So this is showing a multi-batch, this is showing a variable parts. This is a fixed ratio, okay? And so this ratio then, what? It's gonna be a variable ratio. So this is a variable, meaning that N can be anything, depending on however many batches I wanna have. Now, one thing that I want you to be able to do is I want you to be able to maybe show this variable parts with a table as well. So you might need to show students a couple ways that we can see this. All right, so let's go ahead and draw out a table. Okay. This can also be done with a double number line, but we're going to solve with double number lines in 7.2, so I'm going to hold off on talking about the double number line right now. So let's go ahead and draw a table. This is another visual and a way for students to see. So, so this is how many batches. Okay, this would be our juice. Let's see, our juice, and this would be our Sprite. So let's go with 1 batch, 2 batch, 3, and 4. All right, so how many, with 1 batch, is how many parts juice? Well, it's 2 parts juice, right? And 3 parts Sprite. Now, if I have 1 batch, would you agree that I would just times this times 1, times this times 1? Okay, well, what if I have 2 batches? Well, then I have to take this part, I have to double it, and I have to do this part, and I have to double it. Same thing. So this is what this is doing. If I want 3 batches, 2 times 3, and 3 times 3. 4 batches is going to be 2 times 4, and 3 times 4. Okay, and what that does is that just shows the process of what we're doing when we do this. Okay, then that N stands for the number of batches. So it's just another way for students to look at that and recognize that if I wanted to look here, you would see that it's 6 to 9, right? That ratio is 6 to 9. So even if you wanted to do this, that's an option, just to show the ratio marks, okay? So that's just drawing it with a table. Now, here, so what a proportion is, here's a definition of a proportion. It's 2 pairs of amounts that are in the same ratio. Okay, that's a proportion. I'm not sure why my camera is a little delayed, sorry about that, but it's 2, let's say 2 pairs of amounts in the same ratio. And that's going to be, let me move this back a little bit. Okay, that's going to be the definition of a proportion. It's not the Webster's definition, but this is what it means, okay? So let's think about that for just a second. So what if I asked you this question? Let's say we had 1 part juice. Okay, we'll do this juice. And then we had 3 parts of, again, we'll just go with Sprite. All right. So here was your mixture to make your 1 batch. Okay, then I just did this. I'm going to just double that. Okay. Now, it might be easier. I probably should maybe draw it like this. Just, I think that might be a little bit easier to see. Oh, brother, here we go. Can you see that? Okay, here we go. It's a little sloppy. All right, juice to Sprite, juice to Sprite, juice to Sprite. Okay, so here's 1 batch and here's 2 batches. So my question might be to my students, all right, so tell me, is the flavor gonna be different in 1 batch than it is in 2 batches? If I make 1 batch or I make 2 batches, here's my proportions. Is the flavor going to taste different? The juice going to taste different? And that's a great discussion to have with your class, because they're going to say, yeah, because you got more juice, you got more Sprite, so it's going to be different. And you know, ask them why. You know, just see what they're thinking, get in their heads a little bit, see what they're thinking. And then eventually, you know, I think you'll get to that conversation, because one student will recognize that, you know, it's not, because it's still the same proportions. So, you know, 1 juice to 3 Sprites, but in this one I have 1 juice to 3 Sprites and another juice to 3 Sprites. It's still the same proportions. So because it's the same proportions, that means it's going to be equivalent, right? And we're going to talk about equivalent a little bit later. Equivalent, I think I spelled it wrong. Can you see that? And so they are equivalent ratios. So this 1 to 3 and this 2 to 6 are equivalent ratios. All right, they have a different amount, but they're still going to have the same proportion and they're going to taste the same. So when we talk about, I might ask you a question like, well, tell me the difference between a multi-batch and a variable parts. You know, a multi-batch has a fixed ratio, and so the size of everything is 1. So the size of everything is 1. A variable part has variable ratios, which means these are each size 3. So this size is different than this size, and that's what makes those different. Multi-batch is a fixed ratio with a set size. Variable parts is a variable ratio with a different size than the original 1 batch, okay? But they are going to remain equivalent, which means, and that means they would still taste the same no matter what. All right. So that is pretty much what section 7.1 covers. I'm sorry, I got a little sloppy there on it. I got my camera's a little delayed. I'll have to work on that. But in 7.1, there's a couple assignments for you to look at and work on these. But the main key is that you understand fixed ratio, variable ratio, and that you can show models with 1 batch, multi-batches, variable parts, and being able to put it into a table. All right, you guys, have a great day.